So my name is Soham. I'm currently leading the machine learning team at a fintech startup in Singapore called Sleek. I try to make coffee with with high precision grinder, with a temperature controlled kettle, and with a very sensitive scale. I use distilled water that has been specifically, where they've added some minerals in some specific formulas that in percentages that's supposed to make your coffee taste better. I've, I don't buy beans that are like older than that haven't been roasted like more than a week ago. Yeah, I mean, I do all of these things, and my coffee still tastes the same. Actually, it doesn't. It tastes good, but it doesn't taste like where I expect it to taste based on the amount of effort I put in. But the good thing, it smells really great when you grind the coffee. It's very calming, like grinding the coffee and just going through the whole motion of making it. And I think that's the best part. Yeah, it doesn't matter how it tastes. It gives you a sense of calm.
What's up, everybody? This is Dimitrios, and you are listening to another edition of the MLOps Community Podcast. Today, I am graced with the presence of Abby. What is going on, Abby? How you doing?
Not very well. Down with fever. I just took meds.
Oh, no. Oh, I didn't even realize that. We just recorded this whole episode, and you seemed absolutely all together. Everything was fine, so I didn't even think to ask if you weren't doing that well, but I guess you hold your composure well under stress and under pressure.
Well, but it was an excellent conversation. I was actually excited for this conversation. Maybe that's the difference.
As opposed to other ones where you're bored out of your mind and maybe you are in pain, even though you're not sick.
I don't think I've been bored out of my mind in any conversation, but this is also like one of the areas that I'm working in right now. So there's a little bit more excitement. If something is a little bit more recent, there are things that you can learn for the sake of learning. And then there are things that you're like, I'm doing this right now. I'm looking for a new perspective on those things. And I think he had a very interesting idea of, or at least I could say his thought process on a lot of things did align very well with what I've been studying and observing.
Oh my God. So we should probably just mention Soham came on here. He just talked to us about two main themes, one being TinyML and the other being actually using large language models in production. I loved it because it was a refreshingly real take on the pains of using large language models right now in their current state. And he has been trying to use them. I mean, he started using them when there was GPT-2 that was out, and he's continued to use them. And I mean, for me, the biggest highlight was how he talked about, things. It's very easy to stand something up and get that toy demo working really well. But when you want to actually go to scale, that is where it gets really hard. And you can't just rely on OpenAI's API because who knows what their SLAs are. They haven't actually released any SLAs. And you also start paying a lot of money, like really fast. So as a aside, for those who do not know who Soham is, he leads the machine learning team at Sleek, and he builds tools for automated accounting and back office management. He started out as an electrical engineer, which we get into, and he has this passion for TinyML, and he loves talking about it. So we started out with that, and we went down that road for a bit, and the Arduinos, I think is what they're called, and how he loves deploying machine learning on them. And then we went to the opposite side of the spectrum, and we talked about the large language models. So basically, how small can you make the machine learning, and how big can you make the machine learning? Was there any key takeaways that you had before we jump into the actual conversation?
There was one, which was the kind of glass that he looked at coming from TinyML. He said, the scale is quite similar, at least the scale difference ratio, which is earlier we were trying to deploy these models on very tiny devices. And we had the same challenges. These challenges were how much power is it consuming? How much latency does it have? How private data sharing is happening? How much access and control do you have over these models? How are you compressing your models? And most of these things now translate into the realm of LLMs as well. So I love that one.
So good. So he's also got a Substack. I think I found him through Substack, or he came into the community, and he's one of those people that it was obvious when he came into the community that he knows what's up. He's been doing this for long enough, and he's been thinking about it deeply. And so I encourage everyone, if you want more of Soham's work, go and read his Substack. We'll leave a link to that in the description. For now, let's jump into this conversation. And oh, wait, no. Before we go anywhere, it would mean the world to us if you could share this episode with one friend. That would just be incredible. If you know someone that is in this field and would appreciate this type of podcast, please share it, because that's how we can grow and get out to more and more people and hopefully spread the good word. Let's go. Let's do it, Abby, huh? You ready? Here we go. All right, Soham. Just to make sure, am I pronouncing it correctly? So is it Soham?
Yeah, so it's more hum, like humming music.
Yep. In yoga classes, Soham is kind of a popular word that they use, huh? Do you know that? You didn't even...
Yeah, I've heard that. I know that, but like none of the yoga classes I've been to have used that word. So, but yeah, I've heard other people say that.
Yeah.
What does the name mean, by the way?
Yeah.
So from what I understand, it means I am like what I am.
Yeah.
So I guess that can be interpreted in a lot of ways. Yeah, I am what I am,
So accept it. Yeah. Enjoy it. That's all you get.
So exactly.
Oh, dude, awesome. Well, I'm super excited to talk to you because we are going to go down almost like two paths where you do a lot of fun stuff with large language models, but you also have this alter ego that is doing stuff with TinyML. And you mentioned to me before we hit record that one of your passions is to look at how people are using and try and figure out yourself how to use machine learning at the edge. So let's get into all of that. But before we do, I think it's worth just having a bit of a brief explanation on how you came to find yourself where you're at right now.
Yeah, sure. So my background is not in computer science, like at all. I have a bachelor's and a master's in electrical engineering. But I mean, I can't do anything that is electrical related apart from like change the occasional like light bulb, right? So when I was doing my undergrad, right, I this was back in like 2014 or 15, and IoT was like really popular at that time. And what happens in any IoT device is it generates a lot of data. And at that time, there weren't really a lot of people trying to use that data and do something smart with it, right? Or do something intelligent with it. Machine learning and deep learning was just gaining popularity at that time. A lot of people didn't know how to deploy these models really well, or even like how you could use the data and build something smart with it at that time really well. So yeah, it was kind of at that time when I started exploring like how we can take all the data that these IoT devices are doing and build something smart with it. So that path kind of led me down to studying machine learning and then deep learning and then combining IoT with deep learning.
You did your bachelor's in electrical engineering, and then you went on to work with a company called Sama Technologies as a deep learning researcher.
Yeah.
How did that happen?
Yeah, so I was part of this student-run lab in our university where we were just like learning stuff, experimenting with all the stuff, all the cool things that were happening at that time, IoT, deep learning, virtual reality, stuff like that. And so the person who eventually went on to be the head of the deep learning lab at Sama gave a talk at that lab. And that's how we got connected. And when I was graduating, one day he just randomly messaged me on Messenger at that time. I was in the middle of class and he messaged me and he was like, hey, can you come down to our office, which is like a 4-hour plane ride, I think it was.
Wow.
and just like see if you like the vibes, and if you want to join, maybe do an internship or something. Yeah, I was like a broke student at that time, and he
It changed your life.
and like yeah, exactly. So I'm really happy that I got that opportunity. I think it's really hard to get a job in machine learning, especially at that time if you didn't have like a PhD or like or like prior experience. And I'm glad that his name is Malay, by the way. He's still at Sama.
Shout out to Malay.
And yeah, shout out to Malay for giving me the opportunity and trusting me.
So you
Yeah.
ended up with a background which was between deep learning, edge computing, and quantum computing. That's a very interesting combination.
Yeah, I did dabble a bit in quantum computing. I wouldn't say I know like a lot about it. So the research lab at Sama was like we were allowed to experiment a lot and work on things that we thought would benefit the company at that time. So Sama is like a pharma IT company. So we built tools and products for pharmaceutical companies. At that time, a lot of people were using quantum computing to do, I think, protein synthesis and like.
Yeah.
So yeah, we just tried experimenting and seeing if something worked. That's how I dabbled a bit in quantum computing, but yeah, I wouldn't say I'm qualified to talk much about it.
Because you've worked in TinyML, or at least you've explored it, what are some of the challenges that you've seen with deploying machine learning models on TinyML or kind of edge devices?
As far as TinyML goes, what do you consider TinyML?
Yeah, good question. So for me, TinyML, like the really, really tiny ML, it's probably like devices like an Arduino Nano, which has only a few kilobytes of RAM. So, and that RAM has to hold not only your model, but also your code for executing the model, reading data from sensors, processing that data, all of that stuff. That's I think like the really, really tiny stuff. And then what makes it more challenging is if you deploy that device to like a remote area where maybe you don't have access to utility power, right? So you have to run it off of a battery. So how do you make your code like really optimized so that that device can run autonomously for like a year at least?
Yeah.
Yeah. So that would be like the really, really tiny, like at the really edge, right? But then I think, phones right now are really powerful, but that's also, I guess, in some ways, I wouldn't call it TinyML, but it's an embedded device at least. And then another popular embedded device would be a Raspberry Pi. Yeah, so I guess like there's levels of TinyML. You have like the really, really constrained devices with no power, no connectivity, so you can't even make like a query to a server somewhere. And then, those constraints slowly get less and less as you move further up the chain to like a Raspberry Pi and then a mobile phone and so on. Yeah.
And you're playing around with what? When you mess around with TinyML, what is your favorite area to play in on that chain?
Yeah, I think I really like working with Arduino Nanos because that's where it's most challenging.
Yeah, I had a feeling you were going to say that.
How do you even see something work on a device like that? It's probably going to be like an LED that blinks, right? And the joy that a blinking LED can give you, I can't describe the feeling.
Little
So
things.
what are the
Yeah.
applications that you were exploring on these devices?
Yeah, sure. So one of the first applications that I worked on was at Sama. We were working with a medicine manufacturer, and manufacturing medicines, it's highly confidential. You need to have a lot of safety, and there's a lot of protocols around it. So this particular manufacturer, they wanted to make sure that any box of medicine that was going off of their factory, production line had like not only the medicine, but also medicines usually have like a piece of paper with like some information and some warnings on it, stuff like that. They wanted to make sure that all the boxes that they were shipping out had all of those things. And the reason they needed TinyML was because they couldn't make a query to a model out in some server somewhere, because that would be sending like confidential information outside. And then factory floor space is also very expensive. So they didn't want something really large, right? They wanted something small that they could fit maybe next to a camera somewhere. So that was one of the first applications that I worked on with TinyML. What we ended up building for that was, at that time, there was this device called a neural compute stick. And the neural compute stick, it's like a USB, it's like a thumb drive that you can stick on into a Raspberry Pi. And it's called an accelerator. So what it does is you can offload the difficult and compute intensive ML workload on that accelerator, and that accelerator can only execute ML models. It can't do anything else. And because it can only do that, it's really efficient at that. So it can do it really quickly as well. So that was one of the first applications. More recently, I was working with neuromorphic hardware. So when you have to deploy an application to a place where there's no utility power and you have to use a battery, you want to make sure that the devices you're using consume as less power as possible, right? And sensors are one of the most power-hungry devices that you can have in a TinyML system. So one of the solutions is to use neuromorphic hardware, which are very efficient. So we built, and another thing in this field is, the more custom you make your hardware, the more you can save on energy. So what we did was we built a chip that could interface with this neuromorphic camera, and it would consume a few milliwatts of power, and it could monitor, like for instance, you could deploy it in a jungle and you could monitor for movement of cars or any illegal activity, stuff like that.
I love the fact that you mentioned latency, you mentioned size, and you mentioned power energy as well, because there's something you said earlier when we started this conversation, that the scale difference is very similar. How many things or how many operational challenges have you seen transform or come from one domain to this new domain?
Yeah, sure. So latency is the biggest challenge, I would say, because you want your architecture and you want the results from your model to come really quickly, right? So you want to optimize for latency. So that's been a really big challenge. One challenge that, well, it's there in TinyML, but not a lot, is the cost. So at work, when I deploy these large language models, we have to really think about whether it makes business sense to provision an instance with like 1 or 2 GPUs just to deploy a model, because a lot of times just the cost of that doesn't make business sense at that time. So to kind of solve these problems, what people are doing, they're trying to find ways to fine tune the models and compress the models, right? And there's a lot of techniques to do that. For instance, what's the model called? Alpaca model, which was compressed down from a llama model. Similar to how in TinyML we do knowledge distillation, I feel like they've done it similarly, and you have other projects that are doing quantization. What these compression algorithms do is they actually have been shown to increase bias in your models, which has been a huge challenge in TinyML, and I'm sure that'll also come up right now in LLMs as well.
Oh, fascinating. Dude, so I love the fact that you are talking about all these constraints and really looking at, when you're using TinyML, it's because you have certain constraints that you have to fit in. Like there's not enough space on the factory floor, or we can't actually send the data anywhere because that would be illegal. And so it forces you to come up with certain ways of doing machine learning that you wouldn't necessarily think about when you're just at a computer and you're creating some kind of SaaS software, right? Like, I also know that you have a Substack, and that might be what got me hooked on what you've been doing. You talked about building a Chrome app on this Substack, I think, and the different phases of building with large language models. At your job, you're using large language models, right? And you're always thinking about, and from what I understand from talking to you, is that it still isn't really clear if you should be using them or not. And so maybe we could go down that road a little bit, but I also want to hear about your basically your journey when you talk about in your articles on Substack, building with large language models and how you think about those things. And so I'll leave it very open for you to go down whatever path you want, and then I'll follow up with whatever you missed that I still am curious about.
Yeah, sure. So the reason we started this Chrome extension, it's because, well, me and Archana, who I'm building this with, we like anyone else in the field got really interested with LLMs and how they work. But we weren't seeing a lot of people were just building apps and sell it and like hooking it up to and just trying to build a startup around it, right? And in the process, we weren't liking how closed source everything was becoming. I wanted to go back to like a few like the times like we had like a few years ago where people would build something and they would share how they built it, and so that others could learn from it. And
Yeah.
I felt like that wasn't happening, and I wasn't learning a lot about how these models, about the challenges of deploying these models, and what are the constraints when you try to build a product around them. So that's why we thought, okay, fine, let's just build like a toy example and like see what kind of challenges we face and try to solve them and tell people about it, right? What we've learned is what you mentioned, right, from the Substack and like these stages of building a product that uses LLMs. We've learned that if you're like a startup and you want to build an NLP application, it's very easy right now to build that. It's very cheap to just call PinAI's API and have a few prompts and just build a wrapper around prompts. And I think that's the first level of products that we're seeing out there right now, which are and this is this is an oversimplification, but it's basically a wrapper over prompts, right? And what we realized is building a product like that is not feasible, because as your product gets more complex and as you start adding more features and as you try to kind of make the output from your model from the API like more reliable, what you end up doing is you have to create these long prompts. You have to do stuff like just few short prompting is usually not enough. You have to do like chain of thought prompting and even more complex prompts, right? And your outputs also become longer when you go to chain of thought prompting and stuff like that.
Yeah.
And your cost just starts to skyrocket. The model, it's also not that reliable, especially if you try to build chains and agents and where, the output of one LLM API call feeds into another, the reliability becomes even worse.
Yeah. With
So what we
chain,
think will happen,
it goes down and down and down.
Yeah. Yeah. And I've seen people to fix that. What they've done is they have like watcher models that watches the output, checks for checks to see if there's errors happening. And people have built these systems where they also have models that watches for prompt injection attacks and trust issues and watching for incorrect outputs, stuff like that. It it doesn't make sense to me. I don't think that that's something that's scalable. And I don't think that is something that makes a lot of sense from the cost perspective as well. So what I think will happen is people will have to start fine-tuning the models and start to own the models so that they have more control over it, so that they can deploy it on their own servers. So that should reduce costs, right? Because if right now what we pay when we make an API call is on the tokens, which doesn't really make that much sense. And eventually I think as things get more complex, you have to start building custom models. So I've seen a lot of people like become scared, and I was one of them as well. And I thought that, okay, these models with all their emergent properties are going to make data scientists obsolete. I don't think that's the case, because while it makes it easy to build applications, pretty soon you'll have to build custom models. But what I really like about the APIs is how easy it is for a startup to build a product and get it out there really quickly. And nowadays you don't have to be a company with a lot of funding or an incumbent with a lot of data to build these products. You can be, so for instance, our Chrome extension, right? It does, like some changes, like the tone of the text, makes the text more formal, summarizes it, stuff like that. Building a product like that with no data would take us months, right? I don't think any company in the right mind would try to even attempt to do that, because there's just not enough training data out there to do it.
Hey everyone, my name is Aryan, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
But now you can do it, and you can create something very nice really quickly, get a lot of customers, and that's, I think, a really powerful thing about LLMs.
Especially like in machine learning, there was that one phase where everybody was picking up the most optimal model, like everybody was doing hyperparameter tuning. And then eventually people were like, we don't really need to hyperparameter tune that much. We really need to build models that are very specific to domain. And is that something which you're seeing with this as well, which is if we want to run these massive models and to be able to make a business case with them and to be able to scale them, we need to have smaller domain-specific models as compared to larger models because of the reliability and, the other issues which come with scaling.
Yeah, exactly. Yeah, that's what I've been trying to say.
One thing that I definitely wanted to know, but it's totally changing gears. So maybe we can keep going down this LLMs path a little bit, because I do like the idea, and I think it's become fairly obvious that you can validate ideas very quickly with an OpenAI API call, and once you start to hit scale, it very quickly becomes unreasonable. And so it's almost like your success with a app that you built on OpenAI is also your downfall. And especially, I really like what you said, is when you want to start going and making a few calls, or you're chaining things together, or you're making it more complex, that's where you start to see really difficult problems coming in, that it doesn't feel like it's fully solved. And so maybe you have watcher models, and I've heard some really cool stuff that people are working on to try and figure out how to do this. But it is very much like, I guess the big companies have been doing it for a while. Like if you talk to people at Facebook, they're not just using one large language model, they're using a bunch of them together, and each one has its specific task and it's doing certain things. But then you have like so much complexity of trying to get all these models to work together, and how are you calling them? Is it just like 50 API calls? That doesn't really work, because there's not like 50 different models that you can call out to. So it's a little bit of a conundrum right now where we sit. Maybe by the time this podcast comes out, it won't be as bad, because there's some new OpenAI update that changes everything. But I do think that you are hitting on something very, very important that gets swept under the rug a little bit in the conversation. What everyone loves to talk about is how much these large language models have democratized the ability to use machine learning and how you can do so much with them. But then the actual production use cases are a whole different story, because like you said, you still need to have these chops to actually bring the model in-house and then really see actually what part of this gigantic model is what we need, and can we fine tune for that, and actually can we prune it down? Can we get the same kind of benchmarks if we're using a much smaller model? We don't need to use this gigantic model. So I love everything about what you're talking about. It is ringing true on so many different levels.
And I love the part you mentioned on prompt engineering, especially because this is another conversation I've been having with many people. Some are open and saying, let's prompt engineer and get as much optimal performance out of our models as possible. And there's another set of people who are saying, there's human feedback, which is going into these models, which is updating and making these models more powerful as they come in. There's a very good chance that by the time GPT-5 comes out, we may not need to use these prompts as much. So I wanted to get your opinion on prompt engineering, like as a specific discipline as well. And how do you feel like how much prompt engineering would people do in terms of like just a research project or like a toy project versus a production level application?
Yeah, absolutely. And yeah, so it's really hard to talk about these things because like you said, like GPT-5 could come out like, I don't know, in a few days and just make everything I said obsolete, and I'll be like the weird guy with a podcast on YouTube where he just, said random crap.
We're going to date it. Today is
Uh,
April 25th. So in case
Yeah.
by some like stroke of God, GPT-5 comes out tomorrow or between now and when we release this, everyone knows that today when we were talking about this, the world is like we are saying it is. But continue. Sorry, I didn't mean to derail this conversation.
Yeah. No, that's all right. So about prompt engineering, right? When we started building this extension, GPT-4 hadn't come out yet. And the API that was available was the DaVinci 002 API. And we had built like a pretty good, we'd done some prompt tuning, some prompt engineering, and had a set of prompts, and they were working really well. We were getting really good results. But as soon as GPT-4 came out, a lot of those prompts stopped working, or maybe they worked, but they weren't as good. So we had to, so we had a choice at that time, either continue with DaVinci 002 or, move to the DaVinci 003 endpoint. And we didn't really, so a lot of people say that it's really easy to move, but in reality it's not. A lot of the work you've put into prompt, it's very easy to change where you're making the API call, but all the prompt engineering and stuff you've done may be obsolete and may not work. So we decided to, stick with the 002 API. But I think OpenAI, they decreased the amount of load that API could handle. And at times it would take like a minute, maybe even more, to get a response. Especially like I think around February or something, it got really slow. So we had to move to the 003 API. So yeah, so that's also another challenge with prompt engineering, because a new model could come out, your old prompts could become obsolete. It will level the playing field for sure, but at the same time, it reduces the reliability in your product. It reduces, if you have delays or KPIs about how fast, or, you want results to be out there, how trustworthy and how good, if you want to benchmark of your results, you may not be able to maintain that anymore, especially because OpenAI actually doesn't have any SLAs or KPIs for their endpoints.
Yeah.
Right? They haven't come out and said anything official about that. So yeah, so there's that's also another reason why I think it's crucial that you move away from APIs and try to, I don't think it's worth training these models, but at least fine tune these models for your application.
That's so funny you say that. There is something that you mentioned there, which I think that is worth noting. One is that there is no SLAs that OpenAI has set out with, and we probably all have at some point or another gone to ChatGPT and it's like, oh, we're experiencing too much of a load, so let me write you a poem about how we don't have anything working right now. It's like, I don't want a fucking poem, man.
Yeah.
I want to be able to get this, whatever my task is, done. And so if you're building a product that is fully reliant on that API, it's just very scary in my eyes. And I'm sure there's SREs out there that are listening and they're just like, that's a no-go. You cannot do that. And that, I think, is another reason why you see a lot of, it feels to me like there's a lot of great projects that are out there, but they're toy projects, and they're in that first phase of, hey, can we validate quickly with OpenAI? But then we have to figure out something else because we don't know if it's going to be up or not. And then the other thing that I wanted to mention from what you said, and I was just talking to somebody about this yesterday, is if you have, let's say, and this may have been your scenario, I don't know, but you have 300 prompts that you were using with GPT-2, and now GPT-3 comes out. How are you going to migrate everything, all the infrastructure you've created around those prompts and everything over to GPT-3? And then you realize like, oh, half of these prompts don't actually work like they did in GPT-2, you know? So it's just an absolute headache. And especially every time you bring in a new model, it is a little bit weird. And then to top that off, like, let's think about, if you're using GPT-4 for some prompts, but then you want to go to an open source model and it totally reacts completely different. It's like night and day. You can't even use the same prompts at all. And so you have to start from scratch again. And that's just a bit of a mess. And I appreciate that you're pointing these things out because, again, like, a lot of this gets swept under the rug and especially if you hear VCs talking about how this is the future and there's the LLM ops hype that I've hopped on the wave and I love it, but I also am very, very realistic about it. And so.
Yeah. And sorry, I didn't mean to interrupt you, but Abhi also mentioned how these models are also getting better in some ways because they're incorporating feedback. So what you have to do is you have to maintain these prompts, and you also have to maintain like some outputs, and you have to constantly benchmark the outputs that you're getting today with your ideal outputs. And if you move to a new model, you have to do that benchmarking as well. And it's not easy it's possible to do that, but it's not that simple. And especially if you have a lot of prompts, right? And if your application is really complex. So yeah, definitely. I don't see a lot of people saying this, but right now, your prompts are your gold, right? That's what differentiates you from other companies. So you should keep your prompts, locked down as if they were your API keys. That's one thing you should do. And at the same time, you should, because that's, if you come up with a prompt right now is the equivalent of a custom trained deep learning model a few years ago, right?
Your
so you
prompts
need to
are your
keep that
special
locked
sauce.
down. You need to have, exactly. Exactly. You need to keep it locked down. You need to test your outputs with your benchmark outputs. And you need to set up tests for that.
Yeah, I see a new shirt coming. Keep your prompts to yourself.
That's a good one. Yeah. Yeah.
Dude, I want to know. So I got one for you. You've been like really sinking your teeth into all of this. Where do you think you have succeeded where others have failed when it comes to any of this, whether it's TinyML or it's working with large language models?
That's a good question. So with TinyML, I think something that I'm really proud of is the standards and best practices that I've come to learn about TinyML. I've been trying to put that out there and help other people in the field. So I'm really proud of that, I guess. And with LLMs, I think I'm just happy I'm not that caught up in the hype. A lot of people are like so caught up in the hype, they don't realize that these applications don't really work. Like they do work well, but then not, it's not really great for production. And I think that's where we've succeeded.
I think you definitely hit the hammer on the nail. I don't know what the idiom is, but despite the fact that these models are openly accessible via API, they're not open sourced, and they are not as accessible as most people would like to believe that they are.
Yeah, absolutely. It's just, there's very few scenarios where I think it makes sense to deploy an LLM. A hot take, and I might get hate messages after this whole podcast airs, but yeah.
No, it's refreshingly, it's refreshingly real takes, and I appreciate it because, man, there's just something that since like ChatGPT came out, and then if you scroll Twitter at all, your Twitter feed is probably just blowing up with this is changing the world. Nobody knows how to use ChatGPT like I do. Here's the best prompts, or here's like how this is going to change life forever. And there's so much hype in it. And it's nice to actually talk to somebody who's like, yeah, I've been doing this for a while, And here's where there's some real hangups that if you are going to use ChatGPT, you have to think about these things and think through these things.
Yep. I think another thing that me and Aryan are doing really well with this product is we're not trying to get caught up in the hype. We're trying to analyze things objectively and trying to grow the product how we think it would, or trying to build this application and grow it how we think any other application would grow, like add features slowly, verify them, make things more complex slowly. So for instance, right now the next thing we want to do is actually fine tune a model and maybe compress the model and then try that out and see if that helps. We haven't even like tried out vector databases or any of them. It's great. We have those tools, but we haven't really had the need for them. We could integrate them, but yeah, it doesn't make sense.
Yeah, you don't see it yet. So with the compression angle, I find it fascinating that you mentioned it adds to the bias. And also, I imagine you've been trying to figure out, like pruning down these models and also the thing that we didn't say yet that probably needs to be said when it comes to open source models, there's a lot that's left to be desired out there on the open source market. And yeah, there's been some releases or leaks of, like Llama. You can't actually use Llama. You can play around with it, but if you want to create an app with it, you can't. And like that's a whole nother topic for another day. But talk to me about this bias and how did you recognize that there is more biases when you try and compress it? Sorry, not make it smaller.
So maybe I'll take an analogy from TinyML. So one of the people who found out about this bias was this researcher called Sarah Hooker. She has a paper on it. I can't recall the name right now, but it's a really nice paper. I think it goes over the problem really quick, really easy, like in a way that's easy to understand. So how the bias comes out is, let's say you're building a camera trap, right? So it's checking to see if some animal crosses and identify the species, right? You could build a model that identifies like common animals, like, I don't know, like elephants, zebras. I don't like animals that are big. We have a lot of pictures of them. It's easy to and also integrate like other animals that are less common, because that's what you want to capture it in a camera trap, like animals like, I don't know, like a snow leopard or something like that. You won't find them in the same habitat, but like, let's just say you have the same model for that. Now the snow leopard, it'll be in your model, it'll be a part of like the long tail at the end, where you have few images and the model, and your large model might be able to recognize it really well. But what happens when you compress your model is your model will try to optimize for those examples in the data set that it's seen a lot, and forget these at the cost of these examples that it hasn't seen a lot, right? So you'll have a bias towards things that occur more often when you compress down your models. And that's something I think we'll see happen with large language models as well. When we compress them, you might lose vocabulary. You might lose a lot of the richness, I guess, of the larger models when you try to compress your models.
So good, man. Well, this has been awesome, man. And I really appreciate you coming on here and giving this real take. I wonder how things are going to play out, and if it is going to be something that we see people going back to this in a few years and saying like, oh yeah, that was a little bit of a bubble and that was a bit of a craze, like the crypto craze that happened, or if it's just going to continue advancing. And all of this stuff that we're talking about, all these pains that we're mentioning right now, we're going to overcome them in the next couple of years, and we're going to figure out ways to work past them. I'm actually absolutely fascinated by that. And yeah, I think that's it, man. We'll leave it there. Thank you for coming.
Thank you so much for having me.
Hey, I'm Vishnu. I'm a data scientist at First Hand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Dimitrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.